All right, for this section, we're going to be talking about exponential functions. Now, here's the thing, again, we just keep saying it over and again, mathematicians are not creative, so whatever is happening, that's what you're looking at. Look at this exponential function. A function is named by where the variable is. So you look at where the variable is, and in this instance, our variable is in the exponent. So that is why this is an exponential function. That a is just a number. That is just your base value. So your a here is going to be your base, and your x is in the exponent. That's where the variable is. So because your variable is up in the exponent, that is why it's called an exponential function. Pretty cut and dry. All of your bases that we're going to be looking at are going to be those numbers though. So keep that in mind. Your base, which is the a value, is going to be a number, and then your variable is your exponent. When you go to plug these into your calculator, on your calculator there's going to be this button, so it's going to be a button with a caret on it. So you'll have the caret button on there. That a lot of Texas Instruments calculators have that. Some calculators have an X with an exponent to the Y that you can see. It just depends on what your calculator has on it as to what you're going to be using. With these exponential functions, we are going to be using our calculators in order to simplify this. So make sure you have your calculator handy and you're working through these examples with your calculator so that you can check and make sure that your answers are also right. Okay, so for this problem, notice this is f of -1. So that means when I go to plug this in, I'm going to plug that -1 up there where the x is. So that now goes in the exponent. Now, anytime you have a negative exponent, you can make that positive by moving it to the other side of the fraction bar. So if I'm going to take this whole base and the exponent and move it to the bottom of the fraction and make my exponent positive. So whenever I'm looking at this and I have f of -1, that is actually equal to 1/2. When you have these values, make sure you're leaving them as a fraction. I know that you can plug it in and have it as a decimal. However, whenever you do these problems, you need exact answers. If you're asked to round to a certain decimal place, then you can write a decimal if you want. But for the most part, they should be in terms of fractions. Cool, let's do this one. So f of 3, if I'm looking at this, this is now 2 to the 3rd power. Well, what's 2 to the 3rd power? 2 times 2 times 2. That's going to give us 8. So f of 3 is equal to 8. Cool, not too bad, right? You're just putting the variable into the exponent and solving it that way. What if I have something super amazing like this problem where it's to the 5/2 power? Dun, 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 dun. If I'm going to look at this problem, I end up with 2 to the 5/2 power. Now here's the deal. When you have something to a fractional exponent, keep in mind that that is a radical. So what you actually have here is the square root of 2 to the 5th power. We want exact answers on this. Exact answers. So whenever you're going through and you're working these problems, this 5/2 exponent right here, you need to break that down. Anytime you have a fractional exponent where the exponent on top is higher than the radical, then you need to break that down first. So whenever you have this 5/2, you can actually write that as 2 to the 2 and 1/2. Now the purpose for doing something like that is whenever you go to work this problem, you actually have a 2 squared that's set aside here, and you also have a 2 to the 1/2. So remember, if you have like bases, you can add the exponents. So 2 squared times 2 to the 1/2 is 2 to the 2 and 1/2. When you add 2 and 1/2, is 2 to the 1/2. The whole purpose for making that a mixed number is now when you break this down, your 2 squared is a 4, and this 2 to the 1/2 is your square root of 2. So you can break it down to get 4 to the 1/2, or you could take this 2 to the 5th, whatever that is, I have no idea, and you can break it down. You can also look at this as 2 times 2 times 2 times 2 times 2, and because this is a square root, there's a group of 2, there's a group of 2, which is exactly where that 2 comes from. So now 2 groups of 2 come out, so that is where your 2 squared comes out, and then there's just 1 left in. So however you get there, it's up to you, but that's how you get your 4 square roots of 2. Cool. Last but not least on this one is I have f to the 4.92 exponent. So whenever you're breaking this down, this would be a good example of breaking this down on a calculator. So this is really 2 to the 4.92 exponent. The only way to pull that one off is to actually plug it into your calculator and work it out. So remember, you're using that caret button, or depending on what button it is on your calculator, and I'm going to say round to the nearest hundredths position. So this is now going to be 30.273 something something something. So if I round this to the hundredths position, you have 30.27 as that answer. Cool. Awesome. When we talk about an exponential function, I always think it's helpful if you can look at the graph so you can visualize what's actually happening. So think about this. So we looked at a couple examples where we plugged in values. Let's look at this graph here where f of x is 2 to the x. Now look at what happens. Whenever I plug in this negative 2 to my function, so f of negative 2 here that I've already worked out, and if I plug in a negative 2, that gives me a negative exponent. Anytime you have a negative exponent, you move that to the denominator, and that is how you get your 1/4. So notice what's happening here. Even if you plug in a negative value, all that does is put it to the denominator, but it never makes your output over here negative. That is why when I have this graph, I actually have a horizontal asymptote on the y equals 0. Pretty sweet, right? So it's going to get closer and closer and closer to this asymptote, but whenever my numbers get bigger, like this 3 and 8, then it shoots up. So when things say they grow exponentially, that means my graph shoots up really fast. Notice my range, which are the y values, only go from 0 to infinity, and there's a parenthesis on 0 because it means up to, but not including. Cool. Now look what happens if I have a fractional base. Okay, so like for this one, where my base is 1/2, then if I plug in this negative 3, look what ends up happening. Again, I'm going to take a negative exponent. Remember, anytime you have a fraction to a negative exponent, you flip the insides. So this is really 2 over 1 to the 3rd power. And as soon as you flip the insides, you make your exponent positive. So 2 to the 3rd power is now 8. So you start off with a negative exponent, and then you end up with the 8. So you start really big way up here, and then you go down. Notice the same thing is happening. Even when your numbers are big, your exponent is still, you're just taking a fraction to that exponent, and it's always positive. So again, we have this horizontal asymptote at 0. So it's the same deal. Your range is going to be from 0 to infinity because of that horizontal asymptote. Cool. It's always nice, I think, to just look at it and say, okay, why is that negative exponent make that happen? What does that actually look like? So I think it's kind of cool to step back and take a look at the graph. Now, I'm not going to test you on the graphing of these. However, I do think it's a good visual representation, so you see what we're going to do analytically with solving these exponentials. So let's try that on.